Hello, so if you are new to the channel, welcome. And if you're a returning viewer, welcome back. In this video, I'm going to be showing you how to deploy the Mixtral model. So Mixtral has been making waves. It's been making a huge splash in the open source LLM community because as of the time of recording this video, Mixtral is the best performing open source model in the chatbot arena league tables. It even outperforms some proprietary models like Anthropic's Claude 2.1 and also outperforms GPT 3.5. I'll be showing you how to deploy Mixtral for your own purposes. So this will be good for anybody that is an independent researcher, or you're a hobbyist, or you're even doing client demos. I'll show you how to deploy Mixtral using Runpod and the vLLM inference framework. End to end, this deployment pattern is designed to be quick and easy and should only take you about 15 minutes to get set up. There is a small cost associated with this, so you'll need a Runpod account and you'll need at least $10 of credit on that account. You won't use that much for this deployment, but $10 of credit should get you around 9 hours of model use time. I'll be demonstrating how to use the endpoint within a chatbot that I've created in LangChain. Alongside this video, I'll be providing a technical article that will go into a bit more detail about how to use the endpoint within Haystack, LlamaIndex, and also AutoGen. Before I get into the main deployment steps, if you find this content useful, you should subscribe to the channel to receive more content on artificial intelligence and large language models. Remember to like, share, and comment on this video if you do find it useful. Okay, so let's get into the main deployment steps. So stay tuned. It's 15 minutes end to end, and you'll have your own Mixtral model up and running for you to use within your applications. All right, so what you should see on the screen right now is the Hugging Face platform. And this is obviously where we can get a lot of large language models. So you might notice here, I'm using the Mixtral Instruct AWQ, and that's by Casper Hansen. The reason I picked this model out is because we want to use an AWQ model, which is a quantized model, which will load the model in 4-bit. So it's lower precision. And the reason for this is because it requires a lot less hardware to actually run this model rather than running the full Mixtral Instruct model, which would require quite a few GPUs to work. So using the quantized version means that we can get it up and running cheap, and Casper Hansen has kindly provided that. Just for the integrity of this video, I have cloned this repository. So you can see here. So if you are following along with this, feel free to use my clone version. I'll link that in the description to this video. It is exactly the same model as what is in the Casper Hansen repo. It is just cloned across so that this remains constant, because I have no control over what is in Casper Hansen's repo. So I have control over mine, and I know I'm not going to make any changes to this. And that is it. So that's the model we're going to be pulling. The next step that you want to take is to actually assess your hardware. So this is a really important step when it comes to deploying. And if you're using this setup to deploy any other model, you'll want to follow this step. That's made really easy for you by Hugging Face. So there is something called Can You Run It? So that's a Hugging Face space that is available that tells you how much RAM you're going to need to deploy a given large language model. So it's really easy to get up and running with. All we have to do is copy the path to the model, and you can grab that. Hugging Face makes that really convenient for you. You go to the model name here, and then you can press enter. So what Hugging Face will do here is it will actually calculate for you how much memory you need at each precision level. So we're loading this in 4-bit. So we know we need, for just to load the model or just to hold the model or store it, it's around 22 gigabytes. And for inference, we're talking about 26 gigabytes. So we need some kind of GPU to host this model that is larger than 26 gigabytes. That's going to allow us to actually successfully run this. All right. So just to repeat those steps, we're grabbing the model path off Hugging Face, and then we're putting it into this Hugging Face space, which is Can You Run It? I'll just navigate back to that. So it's Can You Run It LLM version. And all you need to do then is paste the model into the model name section. So that's the model path, the complete model path. Press enter, and it will calculate those requirements for you. So you want to make sure you take note of those requirements, because that's going to be important when you're choosing your hardware. Obviously, if you're following along with this, you'll just choose the hardware that I choose. But if you're wanting to do this for a different model outside of Mixtral, you want to make sure that you know the requirements for inference and also for storage. If you are fine-tuning, if you're training full precision, or if you're fine-tuning the entire thing, or if you're doing LoRa fine-tuning, they also provide some estimates of the RAM requirements there too. So make sure you take note of those. All right, let's pull those up so we can refer back to them, and then we'll move on to the next step of getting ourselves set up on Runpod. All right, so we are ready to start building our server on Runpod. So the deployment pattern here is to use the vLLM framework, which is an open source framework that creates an inference server for us. And that's what we're going to be using to run inference over the Mixtral model. vLLM is really good because it's not only efficient, but it creates an endpoint that mimics the API for OpenAI. So it's actually a really convenient way to take your Mixtral model or any other open source model that you want to host and have an endpoint for that model that slots straight into applications like LangChain or LlamaIndex or AutoGen or Haystack, you name it. Anything that uses the OpenAI API currently can be replaced with this vLLM mimicked endpoint. Okay, so now that that's covered, let's start exploring Runpod. So you should navigate to the Runpod homepage as I have done here, and then you can go to start building. So Runpod works on templates first and foremost, right? So a template is essentially a Docker image that you set up, and Runpod will take that Docker image and build it and deploy a Docker container on a hardware of your choice. So that will be a GPU of your choice. And you can see there are quite a lot of GPUs available to you that you can rent out on an hourly basis. What you always want to do is you want to choose the cheapest possible GPU for your model, especially if you're doing something for a client or you're working with a budget that is not unlimited. All right, so let's explore how to actually create a template. What I'll be doing is I'll be showing you one I've created earlier. So if you do want to create a template, all you have to do is navigate to templates, and then you go to new template, and it will bring up this template wizard to help you create that template. So this is the one I created for our Mixtral instruct AWQ model. Let's go to edit so I can show you the details. So when you're creating a new template, you'll just be given this wizard. And what you should do is, first of all, give the template a name that you're going to remember, because you'll need to navigate back to this when you're deploying it. The next thing you want to do is put the container image. So the container image we're using is the vLLM official Docker image, okay? So you can grab that straight from Docker Hub, or what I'll do is I'll provide the link to this image for you in the description so you know where to get the Docker image. So remember what I said about Runpod earlier. When we're creating a template, it's essentially like creating a Docker image, but Runpod itself builds that Docker image for us on the GPU of our choice, and we have a container deployed on that GPU. You'll see how it all works as I run through the process. So that's what you want to do. You want to give the container image for vLLM, and then you want to enter your Docker commands here. So this is quite important that you do this properly, because otherwise you're going to get errors when you are deploying your container. So the first thing is having the host, and you want this host as 0000 because this is operating within a Docker image. And if you want it to be accessible it is operating within a Docker container. So if you want your endpoint to be accessible outside of the container, the host should be 0000. The model is the Casper Hansen model. The cloned version is what I've provided here. So you want to provide, apologies, we'll move that out of the way. You want to provide the path to the cloned version of the model, or whatever model that you want, but just make sure it is the full Hugging Face path that you're providing. If you're using a quantized model, you want to use AWQ for quantization. So these are all Docker commands that you should be setting. And the GPU memory utilization, this tells the engine, the vLLM server, how much of the GPU utilization it should use for inference. Okay, so you want to set this to 1 to use the maximum amount of the GPU. So this is set fractionally. It's between 0 and 1. You want to set it to 1 to enable the maximum amount of GPU utilization. Okay. Now, just a brief thing on the Docker commands. You can actually navigate to the vLLM documentation, and within that documentation, there are other Docker commands for this vLLM engine that we're using. So I'll just show you what that looks like, just so you're comfortable. Because if you are using, so if you go to vLLM engine, it should come up. under the docs. So yes, engine arguments. So all of these Docker commands come from the engine arguments, and you'll want to just make sure that if you're using a different setup or if you're using a different model, that you are covering the right arguments here. So for example, if you're hosting across multiple GPUs, you'll want to look at using tensor parallel size, for example. All right, so back to Runpod and back to the template. So once you have filled out the Docker commands, as I've shown here, the next thing you want to do is allocate some disk and volume space. So this space is important because this is where we're actually storing the model weights, and this should be greater than the combined total of the model. So the model was around 22 gig, if we remember correctly from the from when we tested it in the last step. And the vLLM image, once it's built, is around 3 gig. So I have chosen to allocate about 35 gigabytes of space because you're also going to want space for anything that you're doing within that container itself. So 35 gigabytes of space for this model seems to be appropriate. Now, the volume disk is when you stop the container, you can actually store the model weights in the volume disk. And this means that once you reload that container, once you restart that container, you don't have to re-download the weights and everything else. You can just put it straight from the volume disk. So you want to allocate a similar amount of space in the volume disk too. The volume mount path is standard for Hugging Face models if you're pulling them from the Hugging Face repo. So just provide the path as is here. Lastly, you want to decide the port to expose. So the port I'm exposing is 8000, and that's because this is the port that is exposed within the vLLM inference server. So you'll want to make sure that it's port 8000 that you are exposing. And that is pretty much it for creating the template on Runpod. It is quite straightforward. Just to go over it again at a high level, you want to give it your template a name, give it a name that's memorable for you because you want to recall that later when we're deploying it. The container image should be the vLLM official Docker image, and I'll link to that in the description for this video. There's some Docker commands that you want to set here. So if you're following along with me to deploy Mixtral, you'll set the Docker commands exactly as you see on screen now. And then there are some remaining container arguments, setting the container disk, volume disk, and volume mount path, and the port to expose, set them as you see on screen here. And that is it, really straightforward. We'll come out of that. And the next step, I will show you how to deploy this container. Right, so we have our template set up. The next step is to deploy our container. And we do this by navigating to pods on the menu pane on the left-hand side, and we go to new pod. What you want to do is select the appropriate GPU for the model you're using. In this case, we're using the Mixtral quantized AWQ version. We want to select either the RTX 6000 ADA or the L40. So I'm going to go with the RTX 6000 ADA. And if you recall, remember when we did the can you run it, the inference requirements for the Mixtral model is 26 gig, right? So we have, apologies, navigate back. We have several options here that are suitable for a 26 gig inference requirement. So that's the 48 gig or the 80 gig. The 80 gig in this case is expensive at $469 an hour and $389 an hour. So it's overkill. We want the smallest, cheapest, most performant GPU for our model. And in this case, it's the RTX 6000 ADA. So we just simply hit deploy. And then you'll be presented with this wizard where you'll want to select the template. So I have already selected the template that I built earlier, which is the Casper Hansen Mixtral Instruct AWQ John adding. So select that one. And then you can, at this stage, if you want, you can actually customize the template. So you can go to customize deployment, and that will bring up all the arguments you set before in the template, the container arguments and the Docker arguments, and you can change those here or set overrides here. I'm not going to set overrides because I'm happy with everything. So you can see here, it tells you the compute cost, and this is not the cost of the storage. This is only the cost of the GPU running. If you hit continue, now we've got the running disk cost, so that's the storage cost, the volume cost, and the exited, sorry, apologies, the exited disk cost, which is the volume cost, the running disk cost, which is the container disk, and then the GPU cost, which is $1.14 per hour. If you're happy with the costs and you are ready to go, you can hit deploy. Now, Runpod is actually building that Docker image, and it will deploy that container on this GPU that we have selected, and you'll see that come up now. So what you should do here is navigate to logs, and then you can actually keep an eye on your deployment by monitoring the container logs, which will show you the weights of the model being downloaded into your container. And you can hit refresh here to see how that's progressing along. And the system logs will show you the image and how it's being built. You want to make sure that you keep an eye on these container logs and system logs, because if something does go wrong, you'll be able to spot it here. So this will take some time. I'll leave the video running while it builds so you can see how that goes. Hopefully now the container is built, and we can just check that by going to logs. And if we check the container logs, you can see that it says the application startup is complete and the server is running. Right, let's navigate out of the logs and let's connect to the server. So what we do here is on the dashboard, we hit connect, and we'll be presented with an option to connect to the HTTP endpoint. Simply click that, and you'll be presented with a browser. So if you see this detail not found in this black screen, you have done it correctly. This is what we expect to see. What you want to do is take a note of this URL at the top and grab that, because we'll be using that as our endpoint. So let's do that now. I'm going to pull up my application in LangChain. So that's in my VS Code. I'll pull that up and we can see how this works. So before pulling that up, I'm just going to copy and paste that URL. That's the endpoint that we want. So we can use this to mimic the completions endpoint for OpenAI. And then I will navigate to, I'm going to pull up my VS Code with my chatbot code in there. So two things you want to do is, first of all, put your endpoint in here. So I'll delete this and put that URL in. And it's important to note that when you grab the URL endpoint from your browser, it's just going to provide you with this part. You want to attach a V1 on the end of there to mimic the completions endpoint from OpenAI. So remember that you need to attach the V1 on the end. The second thing you want to do is replace the model name here with the model path of the model you're using in your container. So in my case, I am using, if I go to edit pod, I'm using this model path. So this is the quantized Mixtral. So I need to grab that and put that into my application. So let's put that in. And then we can hit save on that. And then the next thing we want to do is run this application. So I'm not going to go through the details of the code of the front end. I'm just going to show you that we can actually deploy the Mixtral model with LangChain. So I'm not going to go through all of the details about how to set up a chatbot in LangChain. But what you want to do if you're using LangChain is to use this vLLM OpenAI Plus, and that will give you the ability to call your endpoint that you've hosted on Runpod. So you can see the setup here is quite simple. If you want this in more detail, and if you want an example notebook, I've provided that in the technical blog that will be in the description to this video as soon as it is published. So keep on the lookout for that. Okay, now that we have everything up and running, let's test our endpoint. So we'll navigate to Chainlit. And then I'm going to run Chainlit run, and what it is, it's chat LangChain.py. And we'll put this here just so it updates as we run. So just to give you a flavor of what I'm doing here, I have asked the chat assistant to be a helpful chat assistant and with a sarcastic tone. So let's see how that works out. So this is just pulling up a Chainlit front end, and all Chainlit does is it's just a quick way to stick a front end on top of your large language model based applications. It's quite good for demos. I've used it for a few client demos. And it's also easy to deploy your chainlit front ends. There's some tools that platforms that you can use to do that, like fly.io, which is pretty handy. All right, so we have our Mixtral agent up and running, and hopefully it should be sarcastic. So let's just test it out by saying hello. So that's running. So it says, hello there, friend. How can I assist you today? Oh, wait, you probably want to talk about something serious and important. My bad. Let's get down to business. Presumptuous. I've spelled that wrong. Let's just go with that. Presumptuous. Oh, I'm sorry if I came off that way. I didn't mean to jump to conclusions. It's just that I'm so used to being asked about the meaning of life, the universe, and everything. But seriously, how can I assist you today? Or are you here to just ponder the mysteries of the cosmos? All right. So, I mean, put it this way. It's weak prompt engineering. I've just said sarcastic and witty tone, but it is working. So we've got our Mixtral endpoint to work. And just to prove to you that it is, we'll go back to Runpod. And you can see, if you go to the logs, you can see where we have been interacting with the model. So you can see this in the container logs. So this 200 message code, which means that it's passed through into the container. Our messages, our request has passed through okay, and it's completed okay. And there you go. You can see here, this is the prompt. You are a helpful chat assistant. Your tone is sarcastic and witty. And then you can see where we've just said hello. And if you recall in the chat, that was our first message, hello. And then let's head back to Runpod again. And you can see all of the messages that have been sent. So this is the response from the AI message as well. You can see there the response to our second message. Hello, friend. How can I assist you today? Or wait, you want to talk about something serious? So the point being here is that we are indeed passing that into the container hosted on Runpod, and we're able to use that in our front end application as an endpoint. And it's really easily done using LangChain. So this is a LangChain chatbot, and we're just using the vLLM OpenAI class that is provided by LangChain to do that. So that is a quick substitution, and we're using an open source Mixtral model here. So you can see that is really easy to do. As you can see, end-to-end, that process was pretty simple. We managed to go from model to deployment in about 15 minutes. I've used this same deployment pattern to get things up and running for clients really quickly. So when I needed to demonstrate a front-end chatbot for a client, I used this deployment pattern to get it up and running. It worked quite reliably for me. I'm aware that there's local solutions that you can use like Llama, but it's not always suitable. So if you are looking for something to deliver for a client, or if you want to run a larger model, this might be the deployment pattern for you. Runpod also does provide a serverless option, and this is if you want to run at a large scale. As I mentioned before, there will be a technical blog that will be put in the description to this video as soon as it's published that will show you how to use this endpoint with LlamaIndex, AutoGen, and also Haystack. If you enjoyed this content, subscribe to the channel to get more large language model and AI related content. Thanks for tuning in, and I hope to see you next time.